Namaste everyone and welcome to session 4 in the series Algebra for CAT, where we are picking certain question types and categories, understanding the theory and concepts behind them, and then making sure that we are able to solve those questions with utmost ease. Let's continue with this session. So today we'll be covering the extension of what we covered in session 3. Let me give you a quick recap and then we'll again, as usual, solve 4 or 5 questions based on the same from previous year's paper. So if you look at this particular category where arithmetic mean is greater than equal to geometric mean as we did last time round, just a quick summary. For x greater than equal to 0, always remember this is greater than equal to 2. For x less than 0, this expression x plus 1 by x will always be less than or equal to minus 2. So whenever you apply any inequality, always remember these two extreme conditions. The second part is the expression could also be expressed in the form of 2 to the power x plus 2 to the power minus x. Remember, both of them are sum of the term and the reciprocal, and each value is positive. So therefore, this will always be greater than equal to 2. This is something that we covered. We also can represent it in the form of logarithms and say log a to the base b plus log b to the base a. Can I say these are terms which are reciprocal of each other? So if the expression for or the values for a and b both are such that they are greater than or equal to 1. So if both a and b are greater than or equal to 1, then we can say that this expression will definitely be greater than or equal to 2, where we can say a and b both are greater than or equal to 1. Whether they are equal or not doesn't matter. So remember, log a to the base b plus log b to the base a will always be greater than or equal to 2. And finally, we understood that the range for cos or sine expressions typically lies between +1 and -1. So based on these simple concepts, let's now jump straight away to some of the questions that have appeared in previous year's papers. So let's look at this question from CAT 2020 slot 2. So just what we saw, we have been given an expression, one is with base A, another is with base B, and this expression cannot be. Now this term that this expression cannot be equal to, this is giving you a hint that somewhere around the lines we are expected to do a range kind of calculation, some minimum, some maximum value. So let's simplify this expression. So I am writing this log a by b to the base a directly as log to the base a minus log b to the base a. So this is my first expression. What is log b by a to the base b? So I can write this as log b to the base b minus log a to the base b. And that's it. This is my expression. Log a to the base a is simply equal to 1. Log b to the base b is equal to 1. There is a plus sign. So 1 plus 1 will be equal to 2. I can take minus common from these two terms. So if I take minus common, I have an expression log b to the base a plus log a to the base b. And remember the inequality that we just covered. For a and b both greater than 1, this expression has a minimum value equal to 2. This is always greater than equal to 2. And therefore, can I say 2 minus 2 minimum will be 0, or this entire expression therefore will have 2 minus 2 minimum is 0 and then will go to negative terms. So understand that this entire expression will have a value less than or equal to 0. Why? Because if we keep this minimum to 2 minus 2, 0 is acceptable. But if the value goes higher than 2, 3, 4, 5, then this expression becomes negative. So the expression is always either 0 or negative. So 0 or negative are acceptable. The only value which is not acceptable is option 3, 1. Simple enough. Let's move towards next question on similar lines. So for real x, the maximum possible value, again, this part of maximum possible value is going to give us the hint that we have to convert this expression into some form of minimum, maximum. So can I say I'll rewrite this expression again for convenience, x upon under root of 1 plus x to the power 4. If I divide both numerator and denominator by x, can I say I'll have in the numerator 1 and in the denominator I'll have the term. Remember, when we are doing so, x cannot be equal to 0. But at this point in time, we are not really concerned with those technicalities because we are asked the maximum value. So when I divide it by x, numerator becomes 1 and the expression here becomes 1 by x outside 1 plus x to the power 4. So if I now take this 1 by x inside, it will become 1 by x square. So effectively, the expression becomes 1 upon under root of this first term becomes 1 by x square plus x to the power 4 divided by x square will be x square. Now, I hope there is no need for me to explain or solve anything. Look at this expression, a positive number and its reciprocal. The minimum sum is 2. We are asked the max value of this. So to calculate max, understand that the denominator has to be minimum. And what is the minimum value of denominator? The minimum value of denominator is 2. So 1 upon root 2, correct answer for this question will definitely be option 3. Again, understand the importance of the concept that we have covered in session 3 along with a quick recap here in session 4. Make sure that you have watched all the 4 sessions so far, all the previously sessions along with this, so that you get a fantastic command over certain question types. Remember, this is a question from CAT 2020 slot 2, and we have seen at least 5 more questions before this in session 3, which are based on similar concept. So let's move ahead to the next question type. Minimum possible value. Again, this minimum maximum is giving you a hint. Let us try and simplify this expression. For x less than 3, can I say 3 minus x will be positive? So somewhere down the line, I have to convert this expression in the form of 3 minus x. Let's simplify it in some way or the other. So we have x square minus 6x plus 10 whole upon 3 minus x. Can I simplify it and say that because I want 3 minus x, let's convert this to some whole square. So the coefficient of x is 6, half of it is 3. So I can convert it to x minus 3 whole square. So understand that I can write it as x minus, so I'll erase this part quickly. I can directly write this as x minus 3 whole square plus 1. Why? Because we can have x square minus 6x plus 9. But effectively the numerator was 10, so I've added 1 separately and then divided by 3 minus x. Whether in the bracket it is x minus 3 or 3 minus x doesn't matter, because ultimately we are doing whole square. So I can rearrange this and rewrite the numerator as 3 minus x the whole square plus 1 divided by 3 minus x. It doesn't change anything at all. Now I can split these two terms and write it here as 3 minus x whole square divided by 3 minus x as the first term, this first term, plus 1 upon 3 minus x separately. So now I can cancel this with this and I have 3 minus x plus 1 upon 3 minus x. Now I don't need to explain, given the amount of questions we have already solved. Given x is less than 3, which is why they have given this x as less than 3, so that we can say for sure that this expression is positive, this expression is positive, t plus 1 by t, k plus 1 by k, x plus 1 by x, always greater than or equal to 2. They are asking the minimum possible value. Correct answer for this question is the option 3. Again, ridiculously easy. Let's move ahead to the next question. Again, the moment you look at the terms x by y and y by x, we should think of arithmetic mean greater than or equal to geometric mean. So they are saying if C is this expression for some non-zero real numbers x and y, then C cannot take the value of. So understand that if I take the two numbers as 16x by y, so I'm taking two numbers as 16x by y and 49y by x. Think of them as AB, two numbers as AB. If I take arithmetic mean of them, this will be a plus b by 2. The geometric mean will be under root of AB. Let's apply that. So I'm just simply applying arithmetic mean greater than or equal to geometric mean. Arithmetic mean of a and b will be a plus b by 2. So I'm writing this as 16x by y plus 49y by x. This whole divided by 2 has to be greater than or equal to the product of these numbers, which is AB. Now, the moment you think of product 16x by y into 49y by x, immediately you'll be able to cancel y with y, x with x. And under root of 16 is 4, 49 is 7, so 4 7s are 28. So I can immediately say that 16x by y plus 49y by x will be divided by 2, has to be greater than or equal to 28. Can I transpose this 2? So I'll have 28 into 2, this can be written as greater than 56. Now this expression is nothing but C. So I'm writing C to be greater than or equal to 56. Now remember, we did this when the expression was considered to be positive. If the expressions individually will be negative, then we can have the other condition, either C is greater than or equal to 56 or C is less than or equal to minus 56. So these two conditions, always remember that when AM greater than or equal to JM is applied, whatever condition you are getting for negative values, always remember the opposite of it. So C will either be less than minus 56 or greater than or equal to 56. So minus 70 is acceptable. 60 is also acceptable because it is greater than 56. Minus 70 was acceptable because it was less than minus 56. Minus 50 is actually falling between this range. So understand that this is our answer because they are asking C cannot take the value. Minus 60 is very much acceptable. No problem in that. Correct answer for this question is option 3. Let's look at one more question on similar lines where we are expected to apply AM greater than GM. Let K be the largest integer such that equation has no real roots. So this first sentence is maybe related to quadratic and discriminant less than 0. But if you look at the last sentence, if Y is a positive real number, then the least possible value of, again, the moment I think of GM, K by 4Y into 9Y, I'll get Y and Y cancelling. So the moment I look at this expression, it automatically gives me a hint that maybe I should apply arithmetic mean greater than geometric mean. So maybe let's try and simplify this part first, that if we want the minimum possible value, I'm taking one of the numbers as K by 4Y, another number as 9Y, and taking their arithmetic mean. So they will be divided by 2. This has to be greater than or equal to their geometric mean. So geometric mean will be under root of K by 4Y into 9Y. I can cancel Y with Y. Effectively, to get the minimum value, I'll have the expression K by 4Y plus 9Y greater than or equal to 2 will get multiplied on the right hand side. So 2 under root of 9K by 4. Can I say 9K by 4? I keep root K as it is and I'll take under root of 9 by 4 separately out as 3 by 2. So I can get this 2 and 2 cancelled. So effectively my answer is 3 root K. That's it. Now I just need to worry about K, which is a subpart in this question where we are asked K is the largest integer such that this expression has no real roots. So let's simplify for this. So we have x minus 1 whole square. I'm expanding this directly. X square plus 1 minus 2x plus 2kx plus 11 is equal to 0. So let me simplify this further. X square, I can take 2x common. If I take plus 2x common, I'll have k minus 1 in the inside bracket. 1 and 11 will make it 12 is equal to 0. So now I have this expression, and for this expression, I know discriminant is less than 0. Why? It has no real roots. So roots are imaginary. So discriminant, if we simplify b square, so 2 square will be 4, k minus 1 square. So b square minus 4ac, so minus 48 is less than 0. So I can cancel with 4, this becomes 12. Effectively, I get k minus 1 whole square less than 12. Now I need k as an integer, and that to a large integer such that this entire whole square is less than 12. Just do hit and trial and think of values. If I put k as 3, 3 minus 1, 2 square, 4 is less than 12. This is acceptable. So k3 is acceptable. K4, 4 minus 1, 3 square, 9. This is also acceptable. So k is equal to 4 is also fine. But the moment we keep, let's say k as 5, 5 minus 1, 4 square, 16 is not acceptable. Therefore, can I say k is equal to 4 is the max integer value possible for k? And that's it. We just need to substitute k as 4. So we'll get our answer as greater than or equal to 3 root 4. Root 4 will be 2. So the minimum possible or the least possible value will be 3 into 2, 6. That's our answer. So not so easy question, not really ridiculously easy, but at least we have made it far, far easier compared to what it was had you not seen the standard category of questions around arithmetic mean greater than or equal to geometric mean. Probably one of the most important varieties as far as your CAT preparation is concerned, and not just CAT, other exams as well, because number of questions that have appeared in TVCS papers from this has been really, really large. So make sure that you remember these. Session 3 and 4 dedicated to this particular category of arithmetic mean greater than or equal to geometric mean. I hope you are making notes, creating a formula book, writing down values and using them for revision regularly, preferably before a mock and maybe sometime after the mock when you are doing the analysis. So if you keep going, keep making notes, understanding concepts, practicing questions. Believe me, getting a fantastic percentile in quant. Forget about clearing section cutoff. If you watch these sessions of algebra, believe me, in the actual CAT exam, there is a good chance that you might be able to solve at least 1 or 2 questions just on the basis of these 4 questions itself, very, very quickly and easily. So stay tuned for more such sessions. That's it from my side. I'll take a leave. Sure.